So today we will be solving the integral from 2 to 6 of e to the 2x plus 3y dx. Now, the first thing we do when we look at this is we can figure out how to integrate e to the x, something simpler. So we want to use what's called u substitution. And to do that, we have to pick what's our u going to be. So our u in this case is going to equal 2x plus 3y. And that means that our du has to equal 2 times dx, because 3y is like a constant, and so the derivative of that in terms of x will be 0. So now I have my u and my du, so I can rewrite my integral here, and I'm going to write just a definite integral, and then we'll bring back the 2 and the 6. So this will be the integral of e to the u times du. And don't forget about this 2 over here. We have to make a 1/2, and I'm going to bring this in the front. So since it's a constant, we can take it out, and it can be 1/2 times this integral of e to the u du. So now we know how to integrate this, because the integral of e to the u is just e to the u. If you don't remember this, it's also the integral of, or it's e to the u and then over natural log of the base, but the natural log of e is just 1. And so that's why e is a special function where when we integrate this, we just get 1/2 e to the u. Normally, if we were just solving the definite integral, we would put plus c at the end, but we don't need that here because we're going to end up plugging in this 2 and this 6. So the c would cancel. So I'm going to write 1/2 e to the u, which I'm going to replace my u back with 2x plus 3y. So I'm going to say 2x plus 3y. And I'm going to solve this from 2 to 6, or integrate this, right, from 2 to 6. So first what we're going to do is plug in the 6 for x. Okay, so we're going to get 1/2 times e to the 2 times 6, which is 12, plus 3y. And then minus, and now I plug in the 2. So I have 1/2 again, times e to the 2 times 2, which is 4, plus 3y. And now we can write this a little bit nicer just by writing the 1/2 once. And you could have done this to start, but now we'll have 1/2, and then we'll do e to the 12 plus 3y minus e to the 4 plus 3y. And this will be our answer for our indefinite integral above right here.